and hello everyone out there.
Okay, welcome everyone, and thank you so much for joining us today. Uh, Before we get started, I would like to personally thank the SOLIDWORKS User Group Network for always sponsoring these events, making sure that they create the right space for SOLIDWORKS users to collaborate, learn, and network with each other. So yeah, thanks to the SOLIDWORKS User Group Network. And also, if there's anyone who is interested to sponsor these events in the future, feel free to contact me directly. I'm very happy to make that happen. So here today we have a very special guest, Chris from Melbourne, Australia. He's working as a senior product design engineer, team leader at Quadlock, and he's here today to talk about advanced tools and techniques in SOLIDWORKS for speed modeling and assembly. And I'll probably say that most of the advanced tools in SOLIDWORKS are overlooked by a lot of SOLIDWORKS users until they meet or they are working on a project which is having very tight deadlines and there's a lot of product variations. I think that's where these advanced tools can be really super helpful. So I really hope Chris will share a lot of insights about these advanced tools and really help a lot of SOLIDWORKS users around the world to make sure that they can navigate those complex geometries with a lot of confidence using those advanced tools. So Chris, welcome to our Tanzania SOLIDWORKS user group. Feel free to share anything with us, and we are really excited to have you, and we hope to learn a lot from you.
Thank you very much. Thank you for inviting me to speak and present. It is not something that I've done a lot of. I will give you a little bit about my background into this, but I really hope that there's something from my presentation that all users of different levels can take away with them. So let me get into it. Now, if there are any audio or video issues throughout, please just put something in the chat so I know. We might have to wait or rejig a few things. Happy to do that, of course. We are beaming live. I'm beaming live from Melbourne, Australia. So the internet there is going from here to there, halfway across the world. We can expect some technical issues today. Here's what I plan to do. So Edward's given me half an hour to talk to you today. I'd like to spend just a minute or two to introduce myself, talk about some advanced techniques focused on multi-body modeling and some of my process along those lines. We'll then look at some techniques for efficiency. So once you know the methods that I use, if they're suitable for your project, how you can actually get quicker and faster. And some touching on that at the end is the speed modeling practice. And I've allowed 5 minutes for Q&A if anyone has any questions throughout. We do have a tools here I'm presenting with the Google Slides. You can see the link at the top of the screen here. If you type that in, you can go and you can ask me a question at any point. Rather than coming up in the team chat on the left here, it'll actually just pop up on my view over on the right of my screen with the Google Slides. So yeah, no quiz from me, but if you do have any questions on the presentation at any time, just pop them in. I'll leave that up for maybe not the entire duration of the slides, but for quite a few of them. So a little bit about me. I am from Melbourne, Australia. I have a Bachelor of Industrial Design from RMIT University in 2007. I taught SOLIDWORKS at that university for 10 years. I was teaching 2 design students, first or second year designers. I reached certified expert in 2013. And I've had a career as an industrial designer and product design engineer spanning over 15 years. I've started in retail displays, but I'd always wanted to be a product designer. I finally got there in 2017, mostly thanks to my SOLIDWORKS expertise. And more recently, I'm the founder of Fully Defined. which is a YouTube channel. We have 150 plus videos, 1,400 subscribers, and growing. It's a product designer's destination for mastering SOLIDWORKS. It's mostly around expert tips and tricks, some of my process, some of my own projects. Teaching SOLIDWORKS from an active designer's point of view, I think that's the major point of difference that I would have from other training providers where they might not be active designers. So yeah, that's something a bit different. Features tutorials, 3D printing, a bunch of Lego work, and speed modeling. And I do have a couple of videos today to show you. I'm also launching a school community. This is just started, soft launch. If you're interested, check it out. It's free to join. It's a place where I can put all of the classes and tutorials that I'm putting together and start to build a small community. There'll be some premium content in the future, but yeah, feel free to check it out if you like. Now, let me get into what I want to talk about today, and that is starting with multi-body modeling. Now, I apologize for this, but I have to stop sharing and reshare to swap over to SOLIDWORKS. I'll just do that now. And I'm going to assume that you guys can now see my SOLIDWORKS screen. Edward, I'll just ask you to give me a thumbs up or say yes that you can see and everything's good.
Yes, we can see the SOLIDWORKS screen. Everything's good.
Very good, thank you. Okay, so first up, we're going to talk about multi-body modeling. Now, this is, I want to make sure this presentation caters for both beginners and experienced users. So if this is too easy for you, please bear with me. I just want to introduce the concepts, and then we'll get into some more advanced topics over the time. So if you're not aware of what multi-body modeling is, instead of modeling one body per part file, it's where you can have one part file with multiple bodies in it. Often, as a beginner, you're taught to do a part file. You'll do your design in that part file. You might put that part file into an assembly and join that together with other part files to make your product design. With multi-body modeling, what that lets you do is, let's say, create your first solid body. In this case, we'll just do a cylinder. And we can see on our feature tree on the left, we have our solid bodies folder. There is one solid body. If we do a second extrude, so let me do something like this, and I'm just going to extrude this one mid-plane, nothing too fancy. And if we just go normal and we just press OK, all right, that has merged that body with the first body. So we still have one single body. When we get into the multi-body modeling, what we're doing is we're editing this feature, and when we're creating it, we're unchecking merge result. So now we have two separate bodies in the one part file, and we can see that in our solid bodies folder here. We have boss extrude 1 and boss extrude 2. The reason we use this, it'll become more apparent as we get into it. The two solid bodies enables you to do different things with those bodies, such as you can make one transparent, you can change the appearance of the separate bodies, okay, and this is different to changing the appearance of the entire assembly or the entire part file. From a very simple level, this is where the starting point. Now, if we look at a section view of these two, we can see that currently there is a section where there's overlap between those two bodies. All right, we'll come back to that in a second. Now, I'll turn that transparency off. I just want to highlight here the edge display. So when I'm talking about edge display, we can see that on these solid bodies here at the bottom, we have a black edge here, we have a black edge up here. But at the edge in the middle where those two bodies are overlapping, there's no visible edge. That's an indicator that in a multi-body environment, you have two parts overlapping. and essentially interfering with each other. Now, for anyone that has experience with surface modeling, you would know that this is different from a surface, because if I create, let's say, a planar surface here, any surface body is going to have a blue edge, a light blue edge, until that surface body is, let's say, knitted to another body. If I do another quick sketch and another surface on this side, I think this will work. All right, so they're separate bodies, but if I knit those two surfaces together, the line between them comes black. All right, so they're essentially joined. Okay, now I'm going to get out of surfacing. We are just focusing on the solids. So if we do that section view, we can see, again, we see that overlap area, which is down here, the dark area. Now, what happens, what we can do then in the multi-body environment is, let's say I want to do a cut through all. So I'm doing a circle, I'm doing an extruded cut through all both. And what I'm going to do is, if I was just to do the default thing and just press OK, you can see here in feature scope, it's got all selected bodies, but auto select. We do a section view. We can see it's gone through all the bodies here. But what the multi-body features allow you to do is edit that cut extrude. And here I can specify, and I can say, actually, I don't want that extrude to go through this body on the bottom. I only want it to go through the red body in the top. So I can get rid of this direction too as well, make this through all, press OK. And now that cut is just removing material from this body here. It's completely ignoring the one at the bottom. All right. You can even change that again to, let's say, I want to reference this body. So I don't want the cut to start at the bottom. I actually want to use the face that I've created here and change my from, so the starting position of the cut, to this face. And so now my cut is using the reference of this second body we've created. It's not cutting through it at all, but it's cutting up through the red body. This is essentially the basics of multi-body modeling, where you can start to build your design, your products, or the, let's say, the fundamentals, the foundation of your product in a solid part file, a single part file, rather than having to go into an assembly. And when you're wanting to make a change on different parts, move from part to part, editing them either in separate windows or in your assembly mode, you know, exiting or entering that edit part mode. Now, there are some other tools that are really relevant for the multi-body modeling. Here, you can see a lot of them on my customized command manager up here. The main ones are combine. Combine allows you to add two bodies together, essentially merge them without using a separate feature. All right, so that puts them back into one. The combine tool also has the option to do a subtraction. All right, so I could say that this is my main body and I want to subtract, sorry, this one, and I want to subtract this. And so it's going to remove that body from one. There are other tools such as indent, which I've only really used more recently, where you can have a target body such as this one at the bottom, and my tool body is the red, and I press cut. Okay, and that's going to remove any material between the two. So you could have a really complex design and cut away based on one existing solid body that's already there. You can edit the indent tool to give it an offset as well. So let's say I want some clearance around this. I can put 0.5 millimeters in, and that one has gone on the wrong direction. Let me flip it to the outside. That's going to give some clearance around that body. And then the very last one is delete and keep bodies, which is here. So this lets you just remove things or add them back in, or just keep them as you're going. Now, the way I use multi-body tools is in the creation of a new product, and the way I term that is a master part. And I'm going to show you that in the next video here. So the whole idea about this is that once you create your master part, you can split out the bodies to child parts. So I'm going to show you how to do that. I'm going to swap over again and we're going to try video. And this will explain the next portion of the design. So let's say you've already created a design. This example here was using a toy bear, which had multiple parts. It had a couple of feet, a head, some connecting elements, a body, and that was all done in one single part file. Let's check out this now and see if this video will play for us.
And show you the difference between the two files. And now to create or to work from this master file into my new part. So what my aim here is to do is to again split those parts into child parts and then put them back together. I'm actually going to grab a new part file. So instead of doing any sort of feature from here using save bodies or right clicking on a body and going insert into new part, I'm going to start my new part file and then click insert part. And now any documents that are open, it's going to show me a preview. So similar preview to what you might get when you're in assembly mode and you're going to drop a part into an assembly, but there's a key difference here. This is using the insert part feature. And you can see here the open document, and it's the selected, the only open document I have. Now this document only has one configuration, but if you had a part file which had multiple configurations, you could select from which configuration you're going to take your parts. And then under the transfer options, I actually have a series of tools here, which I can select from. Now, by default, usually solid bodies is ticked. You also have the option to select surface bodies, axes, planes, cosmetic threads, absorbed sketches, unabsorbed sketches, custom properties, coordinate systems, model dimensions, whole wizard data, etc., and body and part material. Now, typically, I will only include a few of these. They are usually solid bodies, surface bodies, if I'm using surfaces for reference, and rarely, but sometimes axes and planes as reference geometry, and that's typically it. But
I'm just going to see if I can get that bigger screen for you guys. I don't want it to be too small. I'll
go into an advanced topic in a minute. Now, the other thing that I want to do is, in this case, if I was to press the tick, what it's going to do is drop this part at the origin, matching the original part. So that is perfectly fine. If I was inserting a part in to this assembly and I was wanting to match it to something else, I could use locate part with move copy feature, and I'll show you how to do that in a few minutes. I also have the option here to break the link to the original part. That's something you would want to do if you never want to have it linked back to the original. Typically, I would suggest leaving that unchecked because you want to be able to path your way back to the master file. Different for everyone though. All right. And visual properties, you can propagate from the original part. Doesn't always work, but I'm going to tick that one here. So I'm going to press OK. And there you go. It's brought in my brown bear master file. I have all of the solid bodies here. Okay. And then under that, I can also see the solid bodies. So instead of a imported part like a stock body, I've actually got a feature there which links me straight back to that part file. Now, how do we work from here? Well, what we would do is next.
I just want to touch on this point quickly. There is a multiple, like we know in SOLIDWORKS, there's multiple ways of achieving the same result usually. So if you have a master part file, there are a few ways of splitting bodies out into separate files. One of those is to use the split bodies feature. One of those is to use the save bodies feature. Another one is to right click on a body in that folder and go insert into new part. The issue with a lot of those options is they're very limited with the other data, the other information that you can bring along with the file. Often you'll be limited to only the active configuration, or you'll lose sheet metal properties, or a range of other things. With this process here, although you can't see too much in this example because it's a basic example, you can bring with it any sketches, any planes, any other surface geometry, a lot of other really useful data that can be used to then refine that part even further. And this opens up a lot of possibilities for more advanced processes. I'll keep going with the video now.
Use the delete keep bodies feature. Now I'm going to use keep bodies, and I'm going to select here the main body of the animal, and OK. And that's going to delete all the other bodies. I'm just left with this one. And now this is the one that I would save as that standalone part and then use into going into my assembly. So I'm going to quickly take you through that process. I'm just going to create a folder here. I'm just going to give it a different name to avoid any conflicts if I was to open both files at the same time. So this is going to be my insert part option. So IP, Brown Bear Body 02, and press save. And now that has saved it as a part. Now we don't get the real benefits just yet. I'm going to go through the process for the rest of the parts and then put them into an assembly and then show you the difference.
All right, so what I'm doing in this process here is I'm just bringing each of those parts into their own files using the insert part feature. I'm then deleting or keeping the body, so I've just got the one body that I need. At the end result, I've got all the part files.
We're back. So I've split each file into its own child part. I used a series of save as to save duplicates of each file. And then I changed the delete keep body feature to select a different body. Now I'm ready to create the assembly.
All right, so I'll switch back over again. Sorry for all the switching. It's just what we have to do today. So that's like the first process in creating a product. So with my latest product designs at Quadlock, for instance, the foundation of the product is done in a single part file. And in that single part file, you have all the driving sketches, planes, and features that control the key geometry of the product. I'll do all the major bodies, all the major design elements in that first file. Then I'll split them out to child parts. And in those child parts, I might do some subsequent details such as some draft, or some edge fillets, some part identification. And this helps a lot with your file management. All right, so now we have an understanding of the basics, okay, about the method. We can step up to an intermediate level. Now, this is where, and I'm talking about in that product design, we have a driving sketch or multiple driving sketches within your master part. Doing so gives you all the control you need to adjust your design as you progress through the product development cycle. This video shows the process where I was taking a colleague's file, like from a few years ago. I was cleaning it up so that it did have driving sketches so that I could end up by creating a new product design in our range, which had very similar details. And this was the most efficient way of going about those things. Let me see if I can sort this one out. Getting there.
You'd love to evolve but can't because the model is.
Right.
think fillets and chamfers. Go back to the model.
Apologies,
hard
but
to understand,
here.
not easy to hand over. Here's where we want to get to. Something that's organized, easy to evolve. Okay, let's talk about what's going on here with this time lapse. This is 6 hours of work compressed into 6 minutes. That's 60 times the original speed. So apologies if you can't quite make it out on the video. Did you know that you can hit the YouTube settings icon in the bottom right corner of the screen and change the playback speed? You can slow the video down to 25% of its original pace. So give that a go if there's any little elements here that you want to go back to. Now back to the model. My aim is to maintain the geometry, but clean up the model. We're doing this to make it possible for others to use this model and make changes in the future with minimal fuss. That means removing obsolete features and sketches, moving the driving sketch to the top of the feature tree, or in this case, actually creating a driving sketch, and reordering the feature tree to group associated features into respective folders. As I start this process on this model, I was moving up and down the feature tree to learn about the model and inspect the features that I could do something with. The easiest features to pick out for reordering are edge features, think fillets and chamfers, used on the edges of your model, typically when the rest of the geometry is done. You want to move these to the bottom of your feature tree and stick them all in one folder. Where there are 2 fillets using the same dimension, if they can be achieved using 1 fillet feature rather than 2, then they should. Combine them, then delete the obsolete feature. Keep in mind that edge features used to make major changes to geometry should remain in order with their surrounding features. See example here. Fillet 32, which is a full round fillet done as part of the geometry for the clamp top. The next element to group to second bottom in the tree are any draft features that aren't key to other geometry. This model is of a metal part with CNC finishing, so there aren't any draft features to move here. But in other examples, draft features and edge features are actually done in child parts, not here in the master file. So as I'm progressing through this process, I'm taking note of what the key elements of the design are and giving them names. As I do this, I create folders for these elements and start moving associated features into those folders. There doesn't need to be too many. This model has 10 folders. I'm only renaming key features. Most feature names remain unchanged and are simply grouped into those folders. As you can see, I'm working my way from the bottom up. The trickiest element of this design to maintain while simplifying was the surfacing features of the top clamp. You can see I spend quite a bit of time on this aspect of the geometry. There may have been a simpler method to simplifying this feature, but in the back of my mind, I also knew that I'd be modifying this for the new product I'd be developing. So this leads me to spend extra time on making it robust, meaning when I push and pull the geometry, changing dimensions, the features remain active and error-free. A good way to test your model robustness is to change a few of the driving dimensions and see what happens, but always save beforehand. Now we're nearing a point in the model where I'm comfortable with the reordering that has taken place and what the key areas of the geometry are. So I've got a lot of my folders named and I've started to move a lot of those elements into those folders. Everything now is actually in those folders I've created. My goal now is to bring all of the key driving elements back to a singular driving sketch at the top of the feature tree. Some of these elements are planes that we use as sketch references. My preference when I'm drawing, sketching, is using sketches as sketch references and have it all in one drawing. To replace those planes, I created new sketch elements in the driving sketch, then updated the feature references to refer to that sketch rather than the original planes. Once the references changed, I could go back and delete those planes. And that's what I've managed to do here to clear a lot of those planes out from the earlier sections of the feature tree. Other elements were more complicated. To maintain the shapes and locations of features, we need a workaround to move the sketch up to the top of the tree from where it was down below. There is a method I've used to achieve this quickly, and I've used that repeatedly in multiple models since. First, I will identify the sketch or feature that I want referenced in the main driving sketch. Next, I will create a new sketch below that, convert the required sketch elements, so copy them, and importantly, I then delete the converted entity sketch relation. With no parent relationship associated with a new sketch, I'm able to drag it all the way to the top of the feature tree, And then in my key driving sketch, which would be, 1 or 2 steps below that, I can redraw that sketch element, but now give it relations within that driving sketch. So I'm basically copying a sketch element that's down low, moving all the way to the top to my driving sketch, and then re-adding relations within that sketch to the rest of the model, the rest of the elements, or the origin. Once you've done that, then you go back to the feature that's related to that sketch, or the feature driven by that sketch, change the reference from the original sketch to the new driving sketch. With that done, you can now delete the obsolete sketch, and your model is one step closer to perfection. Now towards.
All right. Now, this is a long one. I just want to make sure that we're getting the right points across. So I'm just going to flick over now to the next element, which was, all right, that last one. The end result of that, the end aim was to get to a point with that file, with that product, where everything was controlled sort of from a very high level. I'm actually going to open that file and show you it now. So give me a second, because what we'll see in that is that all the key geometry, it's been moved, and it's very much able to be controlled and manipulated quite efficiently, which was the whole point to it. I'm just browsing for the file. Apologies for the delay. All right, so when we talk about like a master file, this is the example that I'm talking about from a product point of view. This file contains only a low number of parts. So I guess one of the things with the methods I'm showing you today is it does really depend on the type of product design or engineering you're doing. If you're doing products that have, thousands of parts, this process is probably not for you. It's probably more specialized to smaller products, not so much small as in actual physical size, but the number of parts. Now you can see in this example here, I've only got 3 bodies. Okay, only a couple of surface bodies. This is the master part, but everything here is really driven by like this one key sketch, which drives inside, outside diameters and some of the other key features. All right, so I am running a little bit behind, but a couple of things to jump into now, which is now on the efficiency side of things. So how to get better and quicker, and these are, I think, some of the key things that you will be able to take away from this session. So I'm going to look at mouse gestures and hotkeys, and this goes for even advanced users. Even myself, SOLIDWORKS expert for 12 years, I'm still learning certain features. I'm still learning new methods of working, which are speeding up my process. Every time that I can reduce the number of clicks I'm doing, or the number of mouse movements, shortcuts, that multiplies and compounds over time. It can save me a lot of time. So those demos and methods of working show you the how, but to be super valuable to an employer or client, you need to know how to do so efficiently. So I'm going to look at the mouse gestures here. Now, if you don't know what, Abdul, I'll come back to your question. Thank you. So mouse gestures are where you use your mouse, and you can right click to move your mouse around to activate an action. Now, unfortunately, I can see on screen that this is not being brought up in SolidWorks in your view. So even here, yep, that is a real bummer, actually. I'm going to see if there's another way I can share and do that. That's really, really weird. Okay. I'm going to assume, Edward, I'll use you here, that you can't see in these mouse gestures on my screen. I can't see them in there. I can see them on my screen. I can't see them on the shared screen.
Yeah, we can only see the screen.
You can only see the cursor. Yeah, that's okay. Well, Chrome tab window. All right, I'll try this, but it might, because I'm sharing the entire screen, it's going to go, it might go, no. I'll do this, but it's going to be very small for a second. Gesture, now you can see it. So this is where you right click with your mouse. And you can see gestures come up. So where I use gestures a lot is in sketching. Now, to customize your mouse gestures, you want to go to anywhere that you can customize your options. So that can be under Tools, Customize. And these gives you customize options for your toolbars, your shortcut bars, commands, menus, keyboard, and mouse gestures. This is a 49-inch ultra-wide monitor, which is why I didn't want to share the whole screen. That's it. I know it ruins things. Everything looks tiny for you guys. So on the mouse gestures tab, you have the option to enable mouse gestures, so it's not on by default in all cases. So you want to turn that on. You can control in here the number of gestures as well. And you can see you can have like 2, you could have 3, 4, you could have even 12. And you have mouse gestures per, let's say, like current working state. So if you're editing a part file, like you're adding fillets or extrudes, you can have gestures for that. If you're in a drawing or assembly, different ones for those. And in a sketch, different gestures when you're in that area. I've kept it to 8 gestures, and I predominantly use the gestures in sketch mode. Now, you can customize them by, let's say, you can search for like a rectangle, and you can see here, I've got corner rectangle, center rectangle. If I drag that off, that's going to remove it. So I've got an empty slot here. So if I want to put something into this slot, I searched here for rectangle. I'm going to grab center rectangle and drag it over into that slot there. Now, all these positions are actually relative to how you move the mouse. So when I'm in a sketch mode here, so I'm editing a sketch, if I wanted to draw a certain shape, like let's say a rectangle, I know I just have to right click and drag my mouse down, and it's going to start a rectangle tool. Okay. Or if I want to do a line, it's right click and drag to the left. Okay. And then I'm going to have the line tool. Or right click, drag to the right for a circle. And so these things become second nature as you use them over and over and over again. The other one I use regularly in sketches, but also drawings, is dimension tool. I'm sure we use that. Everyone would use that quite a bit. So those mouse gestures do a lot to really just simplify, reduce moving your mouse like from here up to the menu, or sometimes having to even hit like the S key to get to certain other things. Now, the S key there is a hotkey, an example of a hotkey. I'm going to try and see if this will share just from the SolidWorks window, so it's a bit bigger. No, it does not want to share. That's great. Fun limitations of technology. All right, so hotkeys are the other one that can really speed up a lot of your time. And it's a very similar thing. You want to customize your hotkeys. So hotkeys are on the keyboard. And this is where you can combine your right-hand mouse with your left hand on the hotkeys. So, for instance, I have on my right hand, I'm obviously on the mouse, and I might be doing my sketch. I might use the middle mouse button to rotate my view, but then I've created certain hotkeys for like extrude. I've made into using the E key. All right. Or I might have one like a revolve, which I've done into the R key. All right. So simple hotkeys save you a lot of time. Now you can go really hard with how many you want to set up. I recommend you keep a sort of a mental track of the kind of features that you're using regularly. If you find yourself always going to the menu, like with your mouse, to find a button, or even having to go into, the tools here to find something in particular, you can put that on a hotkey. You just need to note it down at some point and go through and find and associate a hotkey for it. Now, I don't have a huge range of hotkeys, but the ones that I do, again, save me a lot of time. The ones that I do have, the letter M for measure. I'm always measuring to check spaces between certain features, particularly in the multi-body mode. All right, that's a really important one. C, I have C for convert. So I'm in a sketch, I want to convert an edge or a face, I just press C, and I've got that edge there ready to go for my next body. I use offset sketch for a similar thing. So I use O for offset. All right. Again, quicker than having to navigate up here, or to press the S key and then try and find offset sketch here. Instead of pressing S key plus offset, I just press O, and it's a bit quicker. I've already mentioned the ones that I've done for extrude. I should also mention I've done the opposite for like cut extrude. So cut extrude becomes Shift plus E, all right, to remove everything. I've got R for revolve, Shift R for revolve, and then two that are really important for multi-body modeling. I for isolate body. Isolate lets me select the body, press I. Now these two are merged. Let me just unmerge them. Okay, but isolate lets you select a body, press I. It's going to hide all the other bodies. All right, so you can just see that one and work on that one at a time. Isolate mode here, there's a few different ways that you can use this as well. You can even save as display states. It's quite handy. Isolate's fantastic. The most important one of all, which we should all know, Control S for save. All right, but bunch of hotkeys and the mouse gestures, combining those together will generally save you a huge amount of time. Edward, I've got 5 minutes left of my presentation. How am I going for time? Should I keep going?
Yeah, yes, you can continue.
Okay, thank you. All right, so the last aspect of all this is how to actually get better as a SOLIDWORKS user. There's only one way to do it. There's no hacks. There's no like shortcuts out there. It is actually just practice. All right. So let me finish off by showing you this. A 5-minute video about speed modeling. This is something I've come across in the last 2 years, but something that has, even in that time, improved my skills and my efficiency. I've learned new tools as well from getting involved in like the online communities and involved in these tournaments and practicing even more. Let's see if this works.
Hi, and welcome to Fully Defined. Today,
and I'll jump into the full screen. Just let that load, and here we go.
I'm talking about CAD speed modeling and how it sharpens your 3D CAD skills. At its core, speed modeling is all about creating models quickly, practicing techniques, and having fun along the way. While it might not be suited for absolute beginners, speed modeling is an excellent practice for those who've already got a solid grasp of the basics. It offers a fast-paced learning environment which can make you far more efficient in your everyday design work when combined with real-world knowledge. In 2024, I was the top-ranked SOLIDWORKS user in Too Tall Toby's World Championship of CAD Speed Modeling. I've been a certified SOLIDWORKS expert for over 10 years, and even I had things to learn from others in the speed modeling community. Let's dig into why speed modeling is such a powerful skill to develop and practice with. I'll discuss the key benefits, essential tools, how to practice, common pitfalls, and how to avoid them. One of the greatest benefits of speed modeling is how it builds muscle memory. Tools, shortcuts, and mouse gestures become second nature through regular practice. This process also hones your design thinking skills, letting you tackle problems under time constraints, which adds to your confidence in handling everyday design tasks. The efficiency gains from speed modeling compound over time, which greatly impacts both the quality and speed of your real-world projects. And if you can cut down modeling time, you'll have more room to explore and experiment with ideas. A big part of speed modeling, especially as you start challenging yourself, is learning to spot and correct mistakes. Every time you find an error, it's an opportunity to refine your skills. Speed modeling naturally introduces small mistakes, and learning to identify and fix these is valuable. This might involve checking geometry, correcting alignment, or fixing issues in the sketch. Over time, this practice builds an eye for detail, so when you're working on real-world projects, you're faster and more accurate. Let's talk about essential tools and shortcuts to get the most out of speed modeling. Learning and applying hotkeys is a huge time saver, and it's useful to have quick access to commands like extrude, revolve, and mirror. Consider which tools you use frequently and how you access those tools during your workflow. If you are constantly moving your mouse to a button or navigating a menu, creating a custom hotkey for that action will save you time. In SOLIDWORKS, I've created hotkeys for my most commonly used tools, such as extrude, cut, revolve, and measure, just to name a few. Customizing your workspace is another step that allows for better flow. And by observing how others use CAD software, you can often pick up slightly faster methods that might not be immediately obvious. Even if small, these efficiency gains compound over time and make a significant difference. One of the best ways to practice speed modeling is through timed challenges, where you race the clock and see how fast you can get to a correct answer. This isn't necessarily about competition. It's more about becoming familiar with the tools and building the mental agility to work quickly. Observing others' workflows can also be incredibly insightful. You don't need to repeat the same models over and over, but by seeing how others achieve similar results in different ways, you're building a toolkit of techniques to bring into your workflow. I've been a SOLIDWORKS user for over 20 years, yet even now, there are still tools that I hadn't seen used before and didn't know what I was missing out on. It's not uncommon to not know what you don't know. Shared knowledge is one of the best ways to find out. And for practice and challenges, I can't go past recommending tootalltoby.com for his free and premium practice models and live challenges streamed almost weekly to YouTube. 3, 2, 1, go. What is the mass of this part in XXX.X? RAM. Check out his site and channel here. Links in the description below. There are some common pitfalls in speed modeling to watch out for. One is trying to add too much complexity to a single sketch, which can make the process slower and harder to edit. Another is sacrificing too much precision in favor of speed. While the goal is efficiency, balance is key. Don't lose sight of accuracy. Speed modeling should improve your workflow, not build bad habits. So focusing on clean, intentional designs is essential, even when working quickly. In the end, speed modeling is about fun and creativity, with the bonus of making you a more effective designer. The skills and efficiencies you gain here transfer directly to professional work, enabling quicker iterations, rapid prototyping, and more design exploration in every project. So dive into speed modeling, pick up new techniques, and see how it shapes your workflow. If you've enjoyed this video,
beautiful. All right. So the speed modeling community has been really fun to be a part of. And I've learned so much from actually watching other users, not even specifically SOLIDWORKS as well. So a couple of users like using Onshape, I can see how they're using contour selection to create geometry. So that's something I actually can do now I do a lot more in SOLIDWORKS I never used to do in the past. So I would always have my geometry, my sketches. I'd trim away everything that I'm not using. I'd spend a lot of time doing that. Sometimes it would take me extra time to then redefine or add new relations or dimensions, that kind of thing. But once I got in my head, hey, I don't need to do that. It's more efficient to just keep the basic shapes there, actually use the select contours features for, extrudes or revolves or whatever it is I'm building. Those processes, like, they start to become ingrained, second nature, and they speed up the entire process. So there is a lot to learn, and a lot of it, like the majority, is free, just costs you some time. So for anyone practicing or looking to practice, highly recommend jumping online, YouTube, Tutorial Toby for one, Fully Defined for one as well, and learning from those resources out there. All right, and that comes to the end. I don't have a final slide or anything like that, but I'd just like to say thank you very much for your patience with some of the tech issues, just flipping between screens and that sort of thing. I hope the audio and the video came through okay. I know some of those time lapses and some of what I'm teaching, it's very compressed, but if it gives you a little bit of a glimpse into what is possible to learn over time, when you get, you dedicate and you find the right kind of teachers or people to learn from, there is a lot of opportunity out there. So thank you very much. I'm sure Edward can share my contact details around. They'll be on the video replay of this, but you can find me at Fully Defined on YouTube. Is probably the easiest place to get me. Thank you. And I'll hand back over to Edward, or open to questions as well.
Thank you, Chris, for your insightful session. We really learned a lot of things. So I really hope everyone has something to say or ask. You can unmute your mic and ask. By allow that, I would like to personally ask you a question. I know you have been in SOLIDWORKS for over 20 years. And what are the things that will give you an advantage to be able to reach at the level that you are right now? Because I've seen participate in competition and winning against other CAD users. So what do you think are the things in your journey that really helps you a lot to stand out and to be able to be in the position that you are right now?
Okay, so your question is kind of, how did I get here to this level of experience, and what were the key things that helped me?
Yes, sure.
Yeah. For one, I've never spent too long trying or learning other software. I have, over the years, spent a tiny bit of time like learning Fusion or learnt Revit or other things, but 99.9% of my time as a designer has been using SOLIDWORKS, like one software. So I've been very dedicated. If I've had trouble or issues, I've never sought to find another software that does it better. I've been focused on SOLIDWORKS. So that has been one benefit. I know of other designers that may work at one employer that uses one software, and then they change jobs and a different employer uses different CAD package. And that can slow down your development over a long period of time. That is one thing that has definitely helped me. The second thing, and probably the most important thing, is actually teaching. So when I started teaching as a SOLIDWORKS user, I'd finished my 4-year degree. I'd been using SOLIDWORKS for 4 years. I was nowhere near an expert. I was probably not the best student using SOLIDWORKS, but I would have been very good. But when I was teaching, I wasn't teaching 4th-year students below me. I was teaching students who were just coming in and learning from scratch. And going through that teaching process, it solidifies in your mind the processes, the workflows. It makes you question the way that you communicate and teach certain methods. And then, like, over time, as you do it, and I did it for 10 years, that helps you refine, you know, everything to do with that subject. And because I was teaching SOLIDWORKS, I was teaching design with that, I learned a lot from my students and that time where I was giving them experience. I think that teaching, sticking with SOLIDWORKS, but also teaching and reinforcing what you're learning and what you're using is probably they're the two most important points, I think. I'm happy to expand further, but I think we'll look at some of the other questions. I can see Justin has a question there coming up in the chat. Justin, happy to take that. M hotkey. I actually use the M hotkey for measure. So in SOLIDWORKS, there is under the Evaluate tab, there is a button for measuring something. And you can use that measure thing on lots of different elements. So you might be measuring a radius. You might be measuring a distance between 2 points or the length of a line, an angle. Where I'm measuring things often is where the geometry that I'm measuring isn't controlled by one simple dimension. It's not controlled by a certain feature or a fillet. It's controlled by multiple things. So I might be measuring because I'm checking the clearance of something or the thickness. I'm doing a section view. I'm doing a minimum wall thickness check. That's where I'll use the measure tool. And that's why I've got that as the M hotkey, because I use that very regularly. Abdullah, I did respond to your question earlier. So Abdullah asks if changes in the master sketch reflect in referenced features in other parts and bodies. The answer is yes. So when you create, in the example I showed with the large handlebar product, where it had like a certain inner diameter, if I would change that master sketch, that inner diameter, everything would like expand or contract based on that. All the child parts, so everything that's made referencing that original sketch will update when you make that change in the master sketch. And that's one of the reasons why that process is so beneficial as a workflow. Great question. Thank you very much. Jay Vivek, move and mirror. I use Alt-M for move and copy bodies. That is another hotkey that I have. But for mirror, I don't use a hotkey for mirror. I'm a button presser for that one. And I can see Lewis's question. Why do models of the same sketch and material sometimes yield different mass or volumetric properties? Well, I would need more context for that one to answer that one. I think if you've got two bodies that are exactly the same geometry, they should have the same mass volume. And then Justin, I can see Justin's question there. Justin, who said in pass because of time and some other advanced topics in the CSWP exam. My recommendation for that, if you're not quite passing, it's just more practice. Find those small tools that can save you time. I think the CSWP is a 3-hour exam or a bit less, maybe 2 hours. If you need to save 20 minutes to get through all the questions, then find what sort of hotkeys, what kind of tools you can use to speed up your process. Those things, as you get more regular use, more experience, you'll bring the time down very quickly. I think by the time that I did the CSWP, I'd been a SOLIDWORKS user for 10 years, I believe. No, maybe 6 years, 6 or 7 years. But I completed the exam with a third of the time to spare. When you're experienced enough, the time won't be an issue at all. Great question, though. Thank you. Yes.
I mean, from watching a lot of YouTube videos, there are a lot of product designers that they always say that if you really want to be a great product designer, you need to master DFM principles, design for manufacturing. Like even if when you are jumping to CAD tools, you need to design models in terms of how the product is going to be manufactured. So for you, is this something that you have been working on in your career, or if there is anything or any material that you use? Can you please share with us your journey in making sure that you understand the manufacturability before jumping into design, especially those mount solutions that you have been showing in your social media pages?
Yeah, that's a fantastic question, Edward. As a graduate designer, so when I finished university, I had zero design for manufacture knowledge. And that was, I'm not going to say that was a barrier to me getting a job as a product designer, because as a graduate designer, not many have that experience. Learning about design for manufacture really comes on the job, and when you're working with other experienced designers and engineers who can show you the process. I did not learn it from any books. I learned design for manufacture from more experienced designers and engineers. It was my first product design job, but my first product design job was after I'd already been working as an industrial designer for about nearly 10 years, I think, a bit less, maybe 8 years as an industrial designer. As an industrial designer, I learned a lot about metal fabrication. I learned a lot about acrylic bending, a lot about CNC machinery, but I didn't learn anything about injection molding and tooling. Injection molding and tooling was the next level, which once I worked as a product designer and I was designing products that were going to be injection molded and mass produced, and we started to go through the process to really detail parts for those processes, where I learned about how tools are made, how to do texturing, what the limitations are on different textures, and what kind of draft needs to be added to certain walls. What things like sink marks are, how to properly dimension or detail things like ribs, bosses, heat inserts. Like, there is a long list of things that you need to learn. You can't learn it all from a book. You can't learn it all when you're studying. A lot of it will come with experience on the job. Best thing you can do is find a really good employer or some senior mentors, or hopefully you're working for a company with senior users who will train you and teach you on that process as you go through. I've been fortunate enough to do that. Now that I have that knowledge, that puts me in a really strong position as a designer, as a product design engineer, because I can do everything in 3D and I have all the knowledge that I need to apply to that. So I get the information from we have some tooling specialists in-house at Quadlock. He'll tell me what we need to do. I understand it. I can do that in 3D CAD very efficiently, and that's how we can create our products really quickly. Great question, but it's a very tricky thing to kind of learn over time.
Yeah, thank you, Chris, for your answer.
Pleasure.
I think there's a question.
Yep. Which question would you like me to answer?
We have a question from Luis.
Yeah. I think, Lewis, I know the one that you're talking about. I have a video specifically on that CSWA sample examination. There must be something wrong in your model. Sorry to say. But why don't you message me after this? show me your problems, and I'm happy to take you through that at some point. But I reckon the issue will be in your file. Somewhere you might have missed a dimension or had something a bit different. And the question from Justin on 3D printing, for those starters, baby steps. As a designer, if it is possible for you to have a 3D printer, it is a fantastic resource. When I started as a designer, when I finished my university degree and I started working, 3D printers was something that was still years away, too expensive. No one would own one in their home. But now you see printers that are very easy to set up. You get them, you plug them in, you get the material, they're ready to go. I have a Bamboo Lab P1S printer. It's the first 3D printer I've ever owned, but it has been fantastic and the best design resource that I've ever had. So I definitely recommend a 3D printer. Now even the entry-level ones, so the sort of cheaper ones, but if they're good quality, they should be easy to set up, and they will definitely help with your design process when you can 3D print what you're creating on screen.
There is also a question from Joshua. He's saying that he is in the sugar factory with the OT. He was asking if you can prepare in the future a webinar for geometric dimension.
Yeah. Thank you, Joshua, for the recommendation. I'm a bit scared of this one. I'm not a GD&T specialist. I don't follow the exact standards. Often in our drawings, we have too much information. We need to pare them back a little bit, but I know that's different for a lot of different companies and different suppliers. If I find the time and it's something that I think is going to be very valuable for my audience, then I will definitely put together a webinar. So if you subscribe and follow, then at some point we'll get to it. But thank you for the suggestion. All right, I think we might wrap it up there. Edward, I'll stay on the call, see what else you guys got going on, but thank you very much, everyone, for your questions and for your attention in watching me today.
Yeah, thank you, Chris, also for dedicating your time. I know it's pretty late there in Australia and you're about to sleep now. So thank you so much for dedicating your time and present to the SOLIDWORKS user group community. So we are really looking forward for future events. And yeah, thank you so much, Chris.
Pleasure. Thank you all. Best of luck.